Well, I don't know if it's fortunate to be last in the day, but I'll take what I get. So here's Safe Harbor. I'm a product manager. I'm surprised legal didn't ask me to wear one of those A boards. Everything I say is future-facing and may or may not come to fruition, but what I'm going to show you today is pretty cool stuff that some of it we have shipped and some of it we are working on. So I'm Vic Soares. I'm a product manager for a team at New Relic called Connectivity. We don't really have, say, a product like APM or browser. Our team's mission is to bring different parts of New Relic together to facilitate like that interaction, that troubleshooting that you do so often, so you don't have to jump from product to product, that you get a lot of context from the various products together. So that's our team's mission. That's my job as PM. So I'm going to show you a few things that go along those lines. So we touched a bit on the keynote that things are changing with the way folks have been developing software in the last few years. Diversity of tools has increased a ton. Folks are using languages and frameworks and different types of platforms. So you know, when I was an engineer back like 10 years ago, I was writing Java apps. We were deploying maybe once a month, if we were lucky. More often, it was once a year. Then things started evolving. We were able to deploy once a week. We had build pipelines. But things are a lot different today where folks can deploy many times a day, choose the best technology for the job, et cetera. So part of what's driving that is the trend to move away from the three-tier architecture, the monolithic architecture. So you can imagine breaking up the Java app into various different services. And those services all could be based on, use different types of technology, different types of languages and frameworks. Essentially, folks can choose the right tool for the job. This is good. As a product owner, I think it's really cool because we can ship faster. We have the ability to, operations feels like we can scale faster. And our engineers are stoked because they can choose the right tool for the job. They're not forced to use a specific language or framework. But these benefits come at a bit of a cost. So this is just a bit of the architecture that you saw today for our NRDB. There's a lot of services. All those services all talk to each other. Some are owned by different teams. And it makes troubleshooting pretty complex. So as a product owner, it doesn't really matter how fast we can go if our quality sucks. It doesn't really matter how cleanly our concerns are abstracted if teams can't troubleshoot and can't find the information they need to fix an error. Software engineers that are trying to troubleshoot their apps can't figure out where the downstream error is coming from, what root cause or possibly root causes are part of what's slowing their app. So with New Relic, we have a few different ways that you can troubleshoot your services-oriented architecture. First one is Health Map. Second one is Service Map, and the last one is Traces. So let's talk a little bit about each. So Health Map helps you understand the relationship between applications and the infrastructure in which they're running. So they help you answer the question of, are my apps and my hosts working the way I think they should be? Service Map helps people understand the application architecture. So it helps you understand how do things fit together. What app talks to what app? What service talks to what service? What databases does this application communicate with? And finally, transactions. Transactions are kind of the feature that I really loved as an engineer using New Relic. I could go in and it was like magic. I could see exactly where time was being spent. So transactions in aggregate help me know where to focus my time because I can focus on the specific transaction that's taking the longest time in the app. But then specific transaction traces help me see at the code level where the performance issues are. So let me cut to a demo, and we'll go through each of these, because I think it's a lot cooler if you see software rather than slides. All right, we're set. So this is Health Map. Health Map is again the feature that helps you see applications and hosts all in one view and the health for each one of those. So what you're looking at here is all the applications in this account for this customer and the hosts on which they're running. So this application here I can see is alerting it's unhealthy. Its app dex is below the threshold that I've defined as healthy for that app. The one host that it's running on is green, so there's no alerts going on right now. These other applications are yellow, so there's some warning violations, but we're not red yet. And all my hosts appear to be pretty healthy. I can change the view to look at the inverse of that. So let me see all the hosts and what applications are running on the hosts. So if you're deploying containers to hosts, this would be kind of the equivalent of seeing what processes are running on that host. So that's pretty cool. You get to see all the information about the kind of high-level information about the host itself. You can like condense the view even more, put this up on a wallboard so your team knows exactly what hosts are healthy, unhealthy. Same thing for apps. So second feature is service maps. And service maps is the thing that helps you understand how things connect. So the cool thing about service maps is you don't have to configure anything. Like, we just discover it for you. So as your apps send metrics, send events, and other data to New Relic, we notice that, oh, this is a metric about an app talking to this other app. This is an event that represents this kind of relationship. So we can click this Discover Your Environment, and it just starts building that out. Now let me zoom in a little bit. So it's really easy to say, okay, so the browser is making calls to the web portal. The web portal makes calls to the inventory service. I can make that a little bit larger. And I can view response time, change the different types of metrics that are here to get a good idea of how performance is on each one of these services. We also pull in databases, so you can look at, for the apps that are running a database or making calls to a database, what the query response time is and what the throughput is to the database. So this gives you a really good sense of what talks to what, no configuration necessary, and you can remove things from the map, you can add things, you can basically create a map manually and save, like, if you're just interested in this subsection of your architecture, you can save that and have that as a custom service map. So the third thing is transactions. So we're looking at the web portal app, and the web portal app has all the transactions listed here. For the plans transaction, I can see that it's like consumes the most total time in the app. So 42% of the time that the app is spent on plans.jsp. Within plans.jsp, I can see, okay, cool. So this green area is the plan service. It's an external call from the plans service to the plan service. And yeah, we can drill down a little bit further and see specific traces, transaction traces for that transaction. So this is an individual request, a single request for a single user that came through. And we can see the breakdown of that request. So most of the time was spent in that external call to the plan service, and the rest of the time was some internal code. So we can dig down even deeper into the trace details and see exactly, like, pretty much no time spent in these methods, but 80% of the time was spent in the plan service itself. I can drill down into that and follow this then to the transaction for that plan service, for the transaction that I'm calling. So it's pretty cool. All right. There you go. So let's get back into the slides. All right. So just a quick recap of what we've seen so far. The health map shows us how infrastructure impacts application health and vice versa. The service map gives you the full picture on how things connect. And then transaction traces show you that relationship between code, performance, and errors. So that's pretty cool. But if you remember back in the slide, we're like breaking down monoliths where we have many services running. We have lots of infrastructure that is coming up and getting killed. So this doesn't seem like it's quite enough. I think we can do a little bit better. So AJ showed this morning, distributed tracing, that new feature that we're developing. And the idea is when a request comes in from a mobile app, a web app, that request travels through many different services on its way to returning the page to the user. So when a mobile developer is developing an application, or even like, this applies to any sort of service owner, as they're developing their service, developing their app, they're hitting an endpoint, or they're hitting an API. And that API may call other APIs and so on. And if you have latency issues, or you have errors, or you're trying to improve something, it's really hard to like cross those team boundaries or know what teams you need to go talk to. So when you look at a distributed trace, you're seeing all of the different services that were involved in that specific request. You're seeing the duration of the service, how long it took, and you're seeing that in like this kind of like Gantt chart waterfall kind of flow. So you get a really good idea of what's involved, how long it takes, and what the sort of dependencies and relationships are. So let's go into the live demo sequence again. All right. So here we have a list of traces for requests made from the mobile app. So this is the mobile app that the Insights mobile app that you can make queries from, or you can load dashboards from. That mobile app is going to make a request to populate a chart with some information. That request is actually a query to our New Relic database, NRDB. So for each of these requests, it represents that one user's request all the way through an end-to-end system. So let's click on one. And we can see here that there were 6 services involved, 398 segments, and a little under 5 seconds to complete the request. We break things down into sort of logical groupings of the type of, and maybe I'll blow this up to make it a little bit easier to read, the type of segment that this is. So for mobile requests, we color it purple, so it's really easy to tell that it's mobile. For an application request, for an application segment, we color it this teal color, so it's really easy to tell what it is. Then for any databases, we have a blue color, and for custom segments, so time spent within a service that we kind of want to know a little bit more details about, we color green. So kind of visually, it gives you a really good understanding of what type of segment this is. So the mobile app made a call to the Insights query API. The query API then made a bunch of really fast calls, some to Redis, some to Postgres. We can click in and get some information about what happened. So I can see what the exact query was that was executed for this request, and I can see like, well, what does it mean? Is 0.72 milliseconds fast? Is it slow? Like, you don't know, but if you have that response time chart for the database, you know that it's within a reasonable response time. So a cool thing is, in a trace that has 398 segments, there's a lot of stuff that happens really fast that you don't really care about. So we collapse all of that and give you a summary. So there were a bunch of fast database calls that were back to back to back to back. There were 18 of them, in fact. They happened in 27 milliseconds. So that's probably not where you want to look. We collapse that to help you focus on what's the most important thing. So we made a call to the API. API made some database calls. Now it made a call to a query router. This query router is responsible for making some decisions about how this query is going to run. So we see that this is, it's an application. And we can see for the application what the response time, throughput, CPU, memory, network, everything about this application, what's going on from the application level and from the host level. So it's great that we can see both of those things all in one spot. So that router then makes a bunch of calls to more routers, because this is a pretty complex query. So it's going to farm out that work out to those routers as well. So then once we come into the actual work that's being done by the query workers, we can see each of those query workers and how those query workers are performing. So again, we have the average response time, and we can drill down into specific things about this query, or about what this worker is doing, the transaction attributes, if you're familiar with New Relic. So we can see some interesting things like for the folks that are maintaining the system, that are running the system, they put in some custom attributes there that help them troubleshoot, like how many files did this have to read to process the query? How many records were inspected to process the query, et cetera. So this is all information that, like, once we built this, our team, our insights team started using it, and they're just like, wow, this is amazing. This is all like right here. So the same thing with a host. You can drill down into the attributes that the infrastructure agent collects. So you can tell what the agent version is, what the OS is, and anything else that's pertinent to your troubleshooting. Pretty cool stuff. As AJ pointed out, we got this kind of like beginning of the idea of how we could use some of the applied intelligence to help you troubleshoot or like figure out what to focus on within a trace. In this specific thing, when you have an operation where like a router is farming out work to a bunch of workers, it's kind of like this fan-out process. All of those workers are essentially doing the same thing, so they should be returning in about that same time. But so it's really easy to tell when you have something that's not performing well, like an outlier. So we go ahead and we show that to you, and we can highlight the hosts that are bad. And in this case, like it could be a configuration problem, like a local cache was not enabled after a restart, or like a config problem that somebody accidentally introduced. We also have the idea of showing you critical path. So you can see, like, the first thing obviously is part of the critical path, then the series of queries that executed, and then the highlighted, hopefully it comes across on the screen, not too washed out, but it highlights the stuff that is part of that critical path, so those long query workers. Cool. So the distributed trace gives you application information, mobile information, in this case mobile, could be browser, gives you the information about your infrastructure all in one view, including databases, et cetera, so you don't have to like hop from screen to screen, you can see it all in one place. Go back to the slides. All right. So I think the cool thing here is that the application is is really central to understanding your whole system. It's like, it's a thing that you think about when you think about performance, you're thinking about how your application is performing. And distributed traces tie that whole thing together. And it loops in infrastructure and your browser and your mobile. So the last thing that I want to share with you today about distributed tracing is our support for open tracing. And a lot of folks, some folks have heard about open tracing. A lot of folks that aren't like as geeky about instrumentation as we are probably haven't yet. So let me be the first to share if you haven't. It's a vendor-neutral standard for instrumentation of code. So what this means is it's not necessarily like a data format or a transport format for how traces should look like or how they should work. It's essentially like an API definition to say, how do I start a timing of something, and how do I end timing, and how do I assign attributes to that? So it's like semantics along with an API. So New Relic can be an implementer of this, and anything that you instrument yourself with a vendor-neutral API will be able to incorporate, create metrics, create events, et cetera. So we're really stoked to be a part of this. We hope that open source projects start using it. We hope to help educate the ecosystem so that more folks can benefit from instrumentation that ships with software. So to wrap up, so we got the health map, service map, transaction traces. Now we have distributed traces, so we can see that end-to-end thing. And we have support for the vendor-neutral open tracing standard. So you heard this morning, we haven't GA'd this. We're not ready yet for an alpha or a beta. We want to show our customers, our folks, how we're thinking about distributed tracing and how to help in this area. And I'm really interested as a product manager to have conversations with a lot of our customers that are building systems like this, so we can figure out, okay, so it's really cool to see a waterfall, but like, what else is there that we can do? And how can we tie in perhaps service maps with that? Like, let's talk about it. I'd love to hop on a call, a Blue Jeans, maybe go visit you. You come visit us in Portland. Either way, I think we can have a lot of conversations about this really interesting topic and see if we can ship something that really is a game changer for y'all and can help y'all. And that's it. Thank you.
All right, and I think we do have a little bit of time for a couple questions. Anybody have questions for Victor? Oh, we got one in the back. All right. Yeah, but then maybe everyone won't be able to hear you.
Do you have any code samples for using open tracing that are readily available so we could start adding that? And also, if we instrument using the open tracing API, does that create new transactions in New Relic, or does it augment the existing ones?
A little bit of both. So any code example you see today with open tracing will be applicable to New Relic. It's a standard, so we're going to implement the standard in a way that will work. For new transactions, what we do for an open tracing span span definition that says that it's a client, then we see that as I forget what the exact semantic, but yeah, child of, like, there's specific tags that mean that this is an incoming request, and then there's specific tags that mean it's an outbound request. So we can translate that into the New Relic definition of a transaction. Then within a transaction, so the request came in, you have different types of things that happen in your code. Some of them are database calls. We'll automatically instrument those using, like if we support that database driver, we'll automatically instrument those. But say you have like really important block of code that's like your own custom code. You can define a span around that code, and we will automatically show that in the trace as well. It's kind of like a good point to make is there's also the New Relic API, the New Relic Language Agent API, which has all the like APIs to do manual instrumentation as well. So you kind of have a choice of using New Relic's manual API that maps very cleanly to our view of the world, like it has richer, deeper features. And then there's the open tracing API, which is vendor neutral, open. We support it as well. So you can pick the best, I guess, the best API for the job.
All right, any other questions? I think there you go.
Is there a plan to integrate service map and health map so that the applications and the infrastructure are mapped together?
So is there a plan to add, like, say, infrastructure to the service map? I think that's a great direction to go. We're working on some improvements to service maps, and the idea of understanding the relationship of an application calls another application, but there's also that other aspect of the relationship that an application runs on a host. That's an important one, and that's something that we're looking into, yes.
All right, and I think that's all the time we have for questions, so give it up for Victor. Thank you.